Okay, subtopic number 6, which is on Kirchhoff's rules. So in this subtopic, you have to be able to state and apply Kirchhoff's rules. So untuk your syllabus, maximum 2 closed circuit loops sajalah. Okay, so we have first and second rule. The first rule of Kirchhoff's is on junction rule. So this is actually a statement of conservation of electric charge. So it states that the sum of the currents entering any junction in a circuit should be equal to the sum of the current leaving that junction. Okay, so if we look at this junction here, the current that is going into this junction is only I1 and I2, while the rest of it is going out of the junction. So the summation of these charges here should be equal lah. Okay, so untuk second rule pula, it is on loop rule. It follows from the laws of conservation of energy. So it states that in any loop, the summation of EMF is equal to the product of current and resistance. The summation of product of current and resistance. Okay, so the sign convention untuk EMF, dia ada difference lah. So it is always drawn from the negative to the positive terminal lah. Okay, kalau kamu lukis, bila kamu start solve the questions, kamu akan start dengan lukis dulu EMF punya direction. So kamu perlu ingat, it is going from the short one to the long one. Okay, so mana tahu kamu dito, mana satu negative, mana satu positive. Basically, the short line is negative, the long line is positive lah. Okay, so bila the direction of loop follows, terbalik. Bila the direction of EMF follows the direction of the loop, EMF kamu akan letak positif. Kalau the direction of loop is going against the direction of EMF, kamu akan letak negatif EMF di sini. Macam itulah. Okay, nanti kamu faham juga. Sama juga untuk product of IR, the direction of loop. Kalau the current flows the direction of loop, it will be positive. Kalau the current is going against the direction of the loop, it will be negative. Okay? Alright. So these are the problem solving strategy untuk Kirchhoff's laws lah. So always start by drawing the direction of EMF from negative to positive, and then draw the direction of current untuk each resistor. Okay, so tidak ada diagram di sini. Okay, so kamu akan lukis current tu dia bergerak macam ni untuk each resistor. Kamu lukis current tu di setiap resistor. Okay. And then you have to apply junction rule. So resistors at the same branch, which is connected in series, will have the same current lah. Kamu tahu juga kan characteristics of resistors in series, it will have the same current. And then you can apply junction rule and then set a direction for the loop. You can either set the direction as clockwise ataupun anti-clockwise, and then apply the loop rule, solve equation using the equation mode in your calculator. And then don't worry if you get negative value of current and EMF. It is actually telling you that the direction of the actual current and polarity of the EMF is reversed to the direction shown in the circuit. So basically, the negative tu bagi tahu direction dia tu terbalik dari yang kamu lukis. Macam itulah. Okay? Okay, now let's look at example number 11. So this one, we have to determine the current and its direction in the circuit. So direction tu dia just positive atau negative lah. Kamu just lukis dia punya direction di dalam diagram. Wait, do you even draw it? No, just kamu perlu lukis lah balik dia punya loop tu nanti supaya kamu boleh senang solve dia. Okay, alright, so now let's firstly draw the direction of EMF. Negative to positive, negative to positive. Okay, so this is your E1. This is EMF 2. So next, kita perlu lukis the direction of current di setiap resistor. So all of these are connected in series, so they should have the same current. Okay, so I'm gonna go from positive to negative kan current. So dia akan beginilah. Kita start dari EMF number 2. Ikutlah kamu mau letak di EMF 2 ka, EMF 1 ka. Basically, actually, I'm gonna do this one EMF 1 sebab saya punya current start dari that cell, okay? And then the current go here. So they basically have the same value of current sebab they are all connected in series. So it's just gonna be I, this is I, this is I. Oh, don't forget that the cell has internal resistance. So, dia akan flow di sini juga. So, kamu perlu consider juga the internal resistance, not just the external resistance lah. Okay? Kalau kamu lupa dia punya internal resistance, kamu punya jawapan akan salah. Macam tu lah. Okay? Alright, now we have to set the direction of loop. So I would always let EMF1 to be positive. Okay, so dia follow direction of the loop lah. So direction of the loop saya tu depends on the direction of EMF. So sekarang ni EMF saya ke anti-clockwise. So I'm gonna do the direction of the loop as anti-clockwise lah. Macam ni. Deh, kenapa buruk betul ni? Okay, so saya akan lukis the arrow macam ni. So if it follows the direction of the loop, it will be positive. Okay, now we can apply the first rule, which is the junction rule. Oh, kejap. Sekarang ni dia tiada junction pula. So sekarang bila dia tiada junction, we don't have to use the first rule lah. So kita just akan use second rule, which is the summation of EMF is equal to the summation of the product of I and R, current and resistance lah. Okay, so sekarang ni kita akan ikut we have EMF1 and EMF2. So sekarang ni direction of the loop, the EMF follows the direction of the loop, so dia akan jadi positive. Lepas tu sekarang ni EMF2 pun sama juga, dia follows the direction of the loop, so it will be positive juga. Okay, sekarang kita akan tengok resistor. So the current goes for flowing through the internal resistance for EMF1 is following the direction of the loop, so it will be positive, so it's gonna be I R1. Okay, lepas tu kita tengok external resistor di sini, so it's gonna be it follows the direction of the loop, so it's gonna be positive. I forgot to label them. It is actually much more easier for you to label each of these resistors supaya kamu ada senang untuk tulis marker substitution lah. Marker pula. Supaya senang untuk kamu substitute. Okay, so sekarang ni kita tahu external resistor. The resistor number 1 is following the direction of the loop. So it's going to be positive. For EMF2, the internal resistance also follows the direction of the loop. This one follows the direction of the loop, so it will be positive. So it's going to be plus I R2. Again, the direction of current follows the direction of the loop, so resistor number 2, so it's going to be I R2. And then for resistor number 3, they follow juga, so it's going to be I R3. Okay. So extract I here. So it's going to be R1, capital R1. And then kita mau cari I. So it's going to be R1 plus capital R1, R2 plus capital R2 plus R3. So it's going to be E1 plus E2. So this is 2 plus 8.5 plus 4 plus 15.1 plus 6.22. Okay, so it's gonna be E1 plus E2, that is 11.5 plus 15, so this will be equal, the current will be equal to 0.74 ampere. Okay, so this is how you apply Kirchhoff's law in a problem. Alright, so example number 12 pula. For the circuit shown, we have to determine the current I1, I2, and I. So this has two loops, and the potential difference across the 6.7 ohm resistor lah. Okay, so this will be hard because I can't really write comfortably. So susah sikit saya mau tulis bagus-bagus. But it's okay. We can do it. Alright, So first, apa kita perlu buat? Kita perlu draw the EMF punya direction. So this is here. This is here. So I'm gonna label them first. So EMF 1. So sorry, can't see it when I draw the direction of the loop. Yang ini begini, yang ini begini. So this is EMF-ish. EMF 2. Okay, so there's only 2 cells. There's no internal resistance. So this is R1, R2, R3, R4. Okay, so we've labeled them. Now we have to draw the direction of current. So positive to negative is gonna be here. Then it splits off here. And then this is I lah. Okay. So they've labeled it for us. Oh, we have another resistor here. Okay, so this is I1. It's gonna be I1. This is I2. And this is our I. This is series, so it's gonna be I1 as well. Okay. Alright, so we have the direction of the current. Now we designate the direction of the loop. So for this one, it's gonna be clockwise. For this one, it's gonna be anti-clockwise. Okay, so that's the direction of the loop. Alright, now we are going to solve it by applying the junction rule. So we know that the total total current going in should be equal to the total current going out of a junction. So we are going to choose junction X. So it's going to be I1 equal to I2 plus I. So this is our first equation that we've created. Now we are gonna look at loop number 1. This is loop number 2. So we are gonna apply junction rule. Okay. So this is junction rule pula, sorry, loop rule, which is the second rule. So this is for loop number 1. It's gonna be EMF 1 equal to I1 R1 plus I R3 plus I1 R4. Okay, so if we substitute the value, it's going to be 12, 3.9 I1 plus 1.2 I plus 9.8 I1. So simplify it, you will get 13.7 I1 plus 1.2 I. So this is your second set of equation. Okay, so now we have to look at loop number 2. Okay, so let's look at loop number 2. So EMF 2 is following the direction of the loop, so it is positive. And then we have the current going against the direction of the loop. So the current number 2 is going against the direction of the loop, so it will be negative I2 R2. And then we have the third resistor here, which is following the direction of the loop, so it's going to be positive I R3. Okay, so substitute the value I2 plus 1.2 I. So I is equal to 9 plus 6.7 I2 over 1.2. So your equation becomes 7.5 plus 5.58 I2. So this is your third equation. So now we can substitute the third equation into equation number 2. So it will be 12 equal to 13.7 I1 plus 1.2, 7.5 plus 5.58 I2. So it's gonna be 12, 13.7 I1 plus 9 plus 6.7 I2. Okay, so rearrange this, solve it. You will get this equation here. So this will be 3. So this is basically your fourth equation. So if you look at here, there is still 2 unknowns. So what you can do is you can substitute this first equation that we've created into this equation here supaya kita dapat 1 saja unknown. Okay? So kamu akan dapat substitute 1 into 4 lah. Okay? So it's going to be 3, 13.7 I plus I2 plus 6.7 I2. Okay, so sekarang ni kita boleh dapat kita boleh wow. Oh, actually I did. Oh, yeah. Still kita dapat 2 unknowns juga. So, still kita perlu substitute lagi. Panjang pula ni. I think if you can cancel, kamu guna bahagi, kamu boleh cancel tu salah satu unknowns. Tapi actually, I don't like when I have to divide something because lalunya saya buat careless mistake, so I have avoided. I always do substitution. I love substitution lah kiranya. Okay? So sekarang ni kita boleh substitute equation 3 into this equation here. Panjangnya. Barulah kita dapat dapat 1 unknown sahaja. Okay? Sepatutnya 3 equation je kita dapat sudah tu. Sebab kita ada 3 unknowns. So we just need at least 3 equations to solve it. Kalau kamu boleh buat bahagi, kamu buat cara bahagi ya. I like substitution more. Tapi cuma jalan kerja dia panjang lah. Okay, so kita dapat this, barulah kita boleh simplify. So, kamu akan dapat negative 1.03 ampere. Okay, so negative tu maksudnya direction untuk current number 2 tu sepatutnya terbalik lah. So, sekarang kita boleh substitute I2 into equation number 3. So, it's gonna be I 7.5 plus 5.58 negative 1.03, so you will get I to be equal to 1.75 ampere. Okay, and then barulah kamu boleh substitute I and I2 into equation 1 tadi supaya kamu boleh cari I1. Okay, so dapatlah I1. Okay, so saya punya jalan kerja panjang sikit. So what you could do is bahagi equation 3 and 4, I think. Supaya kamu boleh dapat I1 je, unknown dia. Okay? So kamu boleh try bahagi punya cara lah, okay? So now we have to determine the potential difference across the 6.7 ohm resistor. So 6.7 ohm resistor is this one. So we can use Ohm's law. So it's gonna be V2, I2, R2. So it's gonna be equal to, what is the value of I2? It is negative 1.03. So negative is just the direction. So you don't have to include the negative, I think. But if we need to, I'll let you know lah, the comment. I'm actually not confident whether I need to include the negative or not. I assume we don't have to because that's just telling you the direction. But actually, if we include the negative, it is telling us that the polarity of EMF2 should be reversed, right? Never mind. Let's just do it this way, but I'll let you know if you need to include the negative lah. I just have to ask my colleague on this because I'm not really sure. But the value of voltage across the 6.7 ohm resistor is 6.9 volt. Okay, so that is how you solve example number 12, and this is basically on Kirchhoff's rules, and I think this will always come out in exam, so make sure you are able to solve this. Make sure you have to be able to solve this lah supaya senang kamu jawab dalam exam. Alright, so that is on subtopic number 6.